Now, if you get this kind of the graph, so what will be your first comment? Most of the students, they will automatically say this is the graph of the tetanus. No, right, this is the graph of the tetanus, but that is not the best option to start with. You should always say this is the effect of increasing frequency of the stimuli on skeletal muscle contraction. Like tetanus, obviously we are getting the tetanus. The tetanus is generated over here. But before that, there are 3 more graphs, right? So this is effect of increasing frequency of stimuli on skeletal muscle contraction. Like in the previous slide, we talked about the effect of 2 successive stimuli on the skeletal muscle contraction. And those skeletal muscle, we just used 2 stimulus, right? 2 successive stimulus. And we were looking for the effect of those 2 successive stimulus if they are given during the latent period or during the relaxation or the contraction. Now, we have increased the number of the stimuli. Instead of the 2, we are continuously providing the successive stimulus. So, if we keep on increasing the frequency, see, as I said, the lowermost line, these fluctuation means one fluctuation means one stimulus we have provided. So, we are providing the multiple stimulus. What is the difference you are observing in all these 1, 2, 3, 4, these basal line? We are increasing the frequency. See, in this one, they are very closer to each other instead of the first one. So, it means we have increased the frequency. Now, in this graph, we are already considering that we are not providing the stimulus in the latent period. If we will provide the stimulus in the latent period, there won't be any additive or beneficial effect because that falls in the refractive period, right? So, we are providing the successive stimuli of the increased frequency either at the initial point like the contraction. Instead of the 2, if we provide the multiple stimuli in the contraction phase, this is the first graph. In the second graph, we have increased the frequency and we are providing the stimulus just at the start of the relaxation phase. And in the third one, we are providing the stimulus when it, like say in this one we can say in the middle of the, not just at the start, like say this is the contraction and it relaxed this much, it came in the middle of the relaxation, then we provide the second stimulus. Second stimulus, we got the additive effect, and when the effect of the second stimulus starts vanishing, like it start relaxing, we provide the third stimulus, and so on. Like when it is reaching almost about the half of the relaxation of the previous stimulus, we provide the next stimulus, right? And in this one, we provided, like say the first stimulus we provided, it contracted, the contraction, before the contraction ended, no sorry, we provided the first stimulus, it relaxed. As it was supposed to end the relaxation, say let me try to draw the diagram, say this is the effect we got, it was supposed to end over here, before just touching the baseline we provide the second stimulus. Now the effect of the second stimulus was about to touch the baseline, we provided the third one, right? ये सीढ़ियाँ बन रही है ना, staircase, like we are walking over the stairs, so that is called as Treppe. Treppe is a German word and it literally means staircase. So when we provide the second stimulus, when the relaxation phase is about to end, we get the additive effect. So the question might be, why we are getting the additive effect? Because of the beneficial. Like in the previous slide, we talked about the beneficial effect. What is it? So that is the first graph. The second one is what we are doing. The first stimulus effect is this one, and when the relaxation reached in the midway, we provided the second stimulus. When the relaxation phase of the second stimulus reached the halfway, we provide the third stimulus, right? So it's almost like the staircase, but staircase was like this way, and in this one clonus, the relaxation period is duration of the relaxation period is lesser as compared to the Treppe. In the Treppe, say this was the relaxation period. Then in clonus, the relaxation period is lesser than the Treppe one. That's the only difference between the Treppe and the clonus. So in the clonus is like, say, I don't know whether you have seen that dance of Hrithik Roshan or not. Like in the first movie of Hrithik Roshan, Kaho Na Pyar Hai. Like he moves his hand, like the wrist is extended, and then say just imagine the scenario, you have extended your wrist and immediately it is about to relax, like say palmar flexion is about to happen, then again you do the dorsal flexion, then palmar flexion is about to happen, then again you do the dorsal flexion. Try to do that thing like dancing. That is called as the clonus. And that clonus, in the clinics you read about this clonus. This is characteristic feature of hepatic encephalopathy. The patient might get that clonus. So that is, forget about that clinical part, that you will tackle in the coming profs. So that is a clonus. So the third one is, we are providing the successive stimuli just at the starting phase of relaxation, just at the starting phase. Like say the first effect of the first stimulus, contraction happen, then the relaxation is about to happen, we provide the second. So it is like, we can say there is increase in the height, but it's kind of smooth way, not in a staircase way, like in this way. That is called as incomplete tetanus. And if we provide further increase the frequency of the successive stimuli, means it contracted, but before the relaxation starts we provide the second stimulus. Then before the relaxation phase of the second stimulus starts, we provide the third stimulus. So ultimately what will happen? We will get a continuous contracted phase. That is called as complete tetanus, right? That is called as complete. So we can say, if we provide the successive stimulus at the end stage of the relaxation, before it ends, then we get the Treppe. If we provide the successive stimuli during the mid relaxation phase, we get the clonus. If we provide the successive stimuli during the just at the initial part of the relaxation phase, we get incomplete tetanus. And if we provide the successive stimuli, increase the frequency of the successive stimuli so much that it falls during just at the starting point of the relaxation, then we get the complete tetanus. Now what all kind of questions you might get? First and foremost will be explain this graph and define all these terms: Treppe, clonus, incomplete and complete tetanus. That you will get. Now examiner might ask, like, tetanic tension and simple muscle twitch tension, what is the correlation between this? It means like the strength of the tension developed in a simple muscle twitch, is it equal or lesser or more than the tension developed during the tetanic contraction? So the answer should be, the tetanic tension, when the tension is developed in a tetanic phase of the muscle, it is 4 times. It is 4 times the simple muscle twitch tension. Means whatever the force generated will be there in the simple muscle twitch, if we multiply it 4 times, that is the tension developed in a tetanic condition muscle, right? So that is the other question you might get. Now can you calculate the stimulation frequency, like what should be the frequency of the successive stimuli? Can you calculate that frequency of the successive stimuli that might end up in generating the tetanus? Yes. What is the formula for that? The tetanic frequency, it is equal to 1 divided by contraction period. Say if the contraction period is 100 milliseconds, so 1 divided by, say not the 100, 10 millisecond, if we take 10 millisecond. So it will be 1 by 10 millisecond, and millisecond is 10 into 10 raised power minus 3. So it should come out as 10 raised power minus 3 plus 3 divided by 10. So it should be 100. So it means if we provide the successive stimuli, the frequency is 100 times within a second. If we provide 100 continuous stimulus in 1 second, then a muscle having the contraction phase of 10 millisecond will generate the tetanic tension. So we can calculate the stimulation frequency at which the summation of the contraction occurs, resulting into generation of a tetanus. That is the other question you might get. Now there must be so many questions regarding this one, like say, can you tetanize your cardiac muscle? You will definitely get this question. Can you tetanize the cardiac muscle? What is your answer? No, we cannot tetanize the cardiac muscle. Why? What is the reason? If we look at the refractory period of a cardiac muscle, see, this is the diagram. If we look at this diagram, this red line, this is the action potential of a cardiac muscle fiber, right? And this one, this is the mechanical event, the contraction and relaxation phase of a cardiac muscle fiber. So this is the absolute refractory period from starting of the phase 0 to the midway of the phase 3. This is absolute refractory period, and from the lower part of the phase 3 till the phase 4, that is the relative refractory period. So if we provide the second stimulus during any phase, whether it is a contraction phase or the relaxation phase, there won't be any additive effect because it falls in the refractory period. So your answer should be no, we cannot tetanize a cardiac muscle. The reason for that is the refractory period of a skeletal muscle is 1 to 3 millisecond. Now the refractory period of a cardiac muscle is the refractory period of a skeletal muscle is 1 to 3 millisecond, and refractory period of a cardiac muscle is 250 to 300 millisecond. So we cannot tetanize a cardiac muscle because the contraction as well as the relaxation, both the phases falls during the refractory period. So that is the other question you might get. If you look at this diagram shows the upper line, this is the action potential of the cardiac muscle, right? And this one is mechanical event. So this action potential, this is the electrical events happening within a cardiac muscle fiber, and as a result of this electrical event, the mechanical event happening, that is the contraction and the relaxation of a particular cardiac muscle fiber, this one. So the from start of the phase 0 to the midway of the phase 3, that is the absolute refractory period, and from the midway of the phase 3 till the phase 4, that is the relative refractory period. So if we compare this absolute and relative refractory period with respect to mechanical event, it covers the entire contraction as well as the relaxation phase. So if we provide the stimulus at any point, either during the latent or during the contraction or the relaxation, it won't provide the additive or beneficial effect to the next response. Why? Because it is falling during the refractory period. So your answer should be no, we cannot tetanize a cardiac muscle. And what is the reason for that? The reason for that is the relative refractory period of the cardiac muscle is 250 to 300 millisecond, as compared to the relative refractory period of a skeletal muscle, that is 1 to 3 millisecond. So because this is almost 100 times of the relative refractory period of the skeletal muscle, so it will cover the entire contraction as well as the relaxation phase. So that's why we cannot tetanize a cardiac muscle. There can be this question like, say, what are the slow muscle fiber and the fast muscle fibers? So can you give me the example of the slow as well as fast muscle fiber? The fast muscle fibers or the fast muscles are, say, extraocular muscle, and the muscles of the fine movement like muscle of hand, right? These are the fast one. And what are the example of the slow muscle? Long muscles of the back, right? Long muscles of back. So what is the function of long muscles of back? To maintain the posture, right? To maintain the posture, they are the slow muscle fibers. They have the slow muscle fiber. So to maintain the posture of a particular person, these muscles, they always have to stay in a contracted phase, right? So for a particular muscle to stay in a contracted phase, it means it has to stay in tetanized condition. So what is the tetanizing frequency for the long muscle as compared to the extraocular muscle? Or we can say, what is the tetanizing frequency of the slow muscle fibers as compared to the fast muscle fiber? Will it be lesser or more? Slow muscle fiber means that the diagram of simple muscle twitch of a slow muscle fiber, it will be slower. It means there will be more or longer contraction phase, right? Because it is a slow one. So, and what is the tetanizing frequency? It is 1 divided by contraction phase period. Okay. So if it is a slower one, the contraction period will be more. So obviously tetanizing frequency will be lesser. So tetanizing frequency for the slow muscle fiber is less as compared to the tetanizing frequency for the fast muscle fiber. So we need very less frequent stimulation of these back muscle to maintain our posture. Just imagine, अगर फास्ट मसल फाइबर की टेटनाइजिंग फ्रीक्वेंसी कम होती तो क्या होता? आप अपनी एक्स्ट्रा ऑकुलर मूवमेंट इधर उधर देख रहे हो और वो टेटनाइज हो जाती तो आपकी कांस्टेंट हो जाती ना, जो आपका विजन है कि आप किसी एक पर्टिकुलर डायरेक्शन में देख रहे हो, फिर इमीडिएटली उधर मूवमेंट करते हो. इफ़ यू ट्राई टू ट्रैक अलोंग द मूवमेंट ऑफ ए, से यू आर सिटिंग इन ए like moving train or moving bus and you continuously keep on changing the focus. So अगर उनकी टेटनाइजिंग फ्रीक्वेंसी कम होती फास्ट मसल की तो आपकी एक्स्ट्रा ओकुलर मसल वहीं पे टेटनाइज हो जाती. सो इट्स ए वे ऑफ ए नेचर टू प्रिवेंट दिस मिस हैपनिंग. से वी कैन से द फास्ट मसल ट्विच or fast muscle fiber have more tetanizing frequency as compared to the slow one. Okay, that's one question you can get. Then one more question you can get is, what is the difference between the tetanus and tetani? Tetanus means a disease that's called as Clostridium tetani. What happens over there in the tetanus? Like say the tetanus and tetani. Tetanus is complete and incomplete tetanus, we know. In the case of tetany, what happens? Due to reduction in the ionized calcium ions, due to reduction in ionized calcium ion, the neuromuscular hypersensitivity will happen. Due to reduced calcium ion, the neuromuscular part will become more sensitive, hypersensitive. Why? Because of the reduction in the calcium will ultimately end up in increasing the sodium membrane permeability. Sodium membrane permeability. If there is more and more sodium membrane permeability, there will be more and more contraction, generation of the actin potential. So it will end up in generating the cramps. Okay, generating of the cramps. So this tetani is happening because of the reduced ionized calcium ion, and this tetanus is happening because of rapidly repeated maximal stimulus during the contraction phase, end of the contraction phase, you can say. Okay, so that's all regarding the generation of tetanus.